All right, today we do logarithms. Log base a of x means a to what power equals x? So for example, first of all, let's take this. We got to change this. Log base 3 of 243 is equal to 5. Yep, log base 3 of 243 is equal to 5. But we're going to express these in exponential form. Logarithms and exponentials are very closely related. They are inverses of each other. Because they are inverses of each other, we like to transfer back and forth between them quite often. So what we're going to do in the first example is we are going to write log base 32 of log base 2 of 32 is equal to 5 in exponential form. So that means I have a base of 2 and the exponent is 5 is equal to 32. Okay. So we are doing the basics, but I want you guys to understand why it works out the way that it does. Okay. In this situation, a log base 6 of 36 is equal to 2. That means what? Okay. Because we aren't simply going to do this, we want to see the applications of logarithms, we must consider another idea as well. Okay? So, think about this. 5 to what power is equal to 25? 2. 5 to what power is equal to 50? 5 to the third is 125. You don't know, right? It might be 2 and a third, but it's somewhere between 2 and 3, right? Here's how we actually solve that, okay? Logarithms solve for exponents. This is so important that you follow this step, okay? You don't have to memorize it now. We're going to do it a lot over the course of the next few days. But what we can do is we can use the inverse of an exponential, which is a logarithm. And if I do that to both sides, okay, let's watch how this works. Log base 5 and base 5 are inverses of each other. My question was 5 to what power gives me 50, so I want to solve for x, correct? These go away since they are inverses, leaving me with x. So I asked you 5 to what power is equal to 50? Whatever log base 5 of 50 is, that's the power. This is a number, and yeah, it's like 2.3 or something like that. But that is how we solve. What are inverses of each other? For example, 3 plus negative 3 gives us, those are additive inverses. 1/2 times 2 gives us, those are multiplicative inverses. F inverse of f of x, do you remember what that is? X. Those are composition inverses, okay? Inverses make things go away. So if that's the case, flip over to your very last sheet. Then we can use that property for a certain for a few meanings. For example, here it says log base a of x equals y, means if you take a to the y, you get x. Everybody agree that's true? Watch how I can also use this inverse property to make this true, okay? I want log base a to go away. What I can use is use its inverse, make it an exponent. So I create a base of a on both sides. Base a and log base a are inverses. They go away and leave you with x equals a to the y. Is that what you have here? Yes. Okay. Now, let's think of it two ways again. Try to wrap your brain around this. Log base a of 1 is 0. That means a to the 0 is equal to 1, right? You've just always gotten used to that process, moving back and forth, right? But you've wondered, why do we move back and forth? Watch. If I make these a base, a and log base a are inverses. They cancel and leave me with a to the 0 is 1. See that? So I actually operate on both sides. Look at the next one. This means a to the 1 is equal to a. Would you guys agree that's true? Again, if I create a base on each side, those cancel, saying a to the 1 is a. Why is this useful? Because look at the next statement. Log base a of a to the x. Log base a and base a are inverses, so they will cancel, leaving you with x equals x. Look at this. A to the log base a. Those are inverses, leaving you with x equals x. Did you know that the log of 100 is equal to 2? What's the base of log? 10. If you don't write a base, the base is 10. Okay? If we do write a base, then it's whatever it is. Here's something else you need to know. Yesterday you learned about a number similar to pi. What was that number? 2.71, which is known as e. It is a number that comes up in nature. So we use natural log, okay? It comes from a Latin expression where they put the, the natural part comes second, and whatever, I don't even remember what L is first. Logarithm is first. So ln of x equals log base e of x, okay? If you have a base of e, instead of writing base e, you just write ln. So this means e to what power? 0 is equal to 1. Is that true? Take something 0 power to get 1. This says the natural log of e is 1. What is the base of log, of natural log? What is the base of natural log? E. So those are inverses of each other. They cancel, and you're just left with that exponent, 1. Natural log, e to the x. Natural log and e are inverses of each other. They cancel and leave you with x equals x. E to the natural log base e of x. Those cancel, leaving you with x equals x. These are some properties, and that's why they work out the way that they do. We will practice this, allow it to sink in. If you don't see it right now, it's okay. Let's practice this a little bit further. E is a base. It's 2.71. It's one that's just, we're going to talk about a lot, okay? As you see here, we're going to talk about this in a second, okay? So, back to our questions that we were doing before. Log base 12 of 1 is equal to 0, okay? I'm going to write this two ways so that you understand. You've always said that this means that, what's my base? 12 to the 0 is equal to 1. All right? Let me show you why that is. You don't have to write it like this, but I want to show you so you understand what the heck it is that we're doing and why we can do it, okay? What is my base? So if I create a base of 12, what happens to this? Cancels, and I get 12 to the 0 is equal to 1, which is what you wrote. That's why that works. You might wonder, why would we ever have to use that? Because we're not going to do problems like this forever. We're going to do a problem like this. We're going to do a 3e to the 4 minus pi x plus 1 is equal to 5. And you've got to be able to solve for x up in the exponent. In order to do that, we are going to have to do some of these inverse operations in equation solving. So we need to get a little familiar with that property. And as we go on, I think you'll have success with it. Okay, so the next one. Log base 3 of 243 equals 5. What does that mean? What's my base? 3 to the 5th is equal to? Good. What? Natural log of e equals 1. What is the base? E to the, what's the exponent? Is equal to e. That's what that says. Natural log of 1 equals 0. What's the base? E. E to the 0 is equal to? Would you agree e to the 0 is 1? Okay, so these are the type of pieces you got to get familiar with. And I know that logarithms and exponentials are, again, it's a deviation for polynomials. It kind of hurts your head a little bit because we don't spend a lot of time with it. But this is all stuff we got to become familiar with. Okay, so you wrote in exponential form. Now let's express these in logarithmic form. 2 to the 4th is 16. What that means is log base, what's my base? 2 of 16 is equal to 4. Because logarithms give you exponents. They allow us to solve for exponents. That's what we write. Now, I'm going to show you once how we use that property to come up with that. If I take the log base 2 of both sides, log base 2 of base 2, what happens to those? Canceling, leaving you with 4 equals log base 2 of 16. And that's what you wrote down, isn't it? That's what actually happened when you were doing that. That's the mathematics that occurred. I'll do it once more with this. If I want to write this, I'm going to take the log of both sides. What should be the base of my log? 10. Log base 10 of 10 to the 5th equals log base 10 of 100,000. Do I have to write the base 10? What happens to log base 10 of base 10? And leaves you with 5 equals log base 10 of 100,000. Now, I know that for today you won't take the logarithm of both sides, but I want you to know that that's what's happening. That's the magic that's occurring. Yes. No. No. This one, I have log. What's my base? 8. And of 1/64 is equal to, what's my exponent? -2. So if I don't do it like that, what I always think to myself is the base goes here and logarithms solve for exponents. It's the other number that goes there. Otherwise, it's like, how do you remember what goes where? You know, I showed you why it works out, but that's how you remember. Log base 7 of 1 is equal to the exponent, 0. Log base, don't have to write it, of equals the exponent. Log base, so natural log of e is equal to the exponent, 1. A lot of people ask, will we use natural log? You use natural log a heck of a lot more than you do logarithms. Natural log comes up a lot more. Furthermore, some people don't like ln. They want me to write it like this, ln. I won't do that because I've never seen any professor do that in my life. Okay? Nor have I seen any textbook write it like that. So I won't do that. Okay, flip your notes over. Evaluate the following. So log base 4 of 64 is equal to some number x. What that means is 4 to the x power is equal to 64. Therefore, x is 3. Very good. Log base 3 of 1/9 means that 3 to some power is equal to 1/9. 3 to what power is equal to 9? No, 3 to the 2 power is equal to 9. So 3 to what power gives you 1/9? Negative 2. Log base 8 of 8 equals x. What number 8? You take the x power to get 8. 1. Now we get to some tricky problems. Log base 5 of 5 to the x plus y. Do you see? What did I teach you? The log bases and the base, they will cancel. Log base 5 and base 5 cancel. They are inverse operations of each other. And you get x plus y. 3 to the log base 3 of 7. What happens to the 3 in log base 3? Cancel, leaving you with 7. Now, somebody asked this question before. They said, what if it's 4 to the log base 3 of 7? Well, that we really can't simplify at all. It doesn't come out to something nice at all. So if it was a 3 in the base, works out nice. If it's not, can't do it. Natural log of 1 over e squared. Would you guys agree that this is the same thing as natural log of e to the negative 2? What's the base of natural log? E. So log base e of base e, what happens? Cancel, leaving you with negative 2. Four says find x. X's are all over the place. They're in different spots now. So this means 2 to the third power is equal to x. So x is 8. This is x to the second power is equal to 100. X is 10. Log base 5 of 125 is equal to x. That means 5 to the x is equal to 125. What is x? 3. D says base x to the 1/2. If you take something to 1/2, what does that mean? Square root. Something to 1/2 is the same as a square root. Is equal to 49. What number do you square root to get 49? 7's a common answer, but it's the square root of 49 that gives you 7. What do you take the square root to give you 49? How would you solve that? Square both sides, you get 2,401. Log base 2 of 0. That means 2 to what power is equal to 0? What's that? Why? Why? Good. 2 to the 0 is 1, right? What's 2 to a negative power? Like 2 to the negative 3. That will give you 1/8, right? And if you notice from our graphs yesterday, if we drew 2 to the x, we crossed through 1, but we never crossed over 0, did we? In fact, we said it will never be equal to 0. So for this, there is no solution. Or you could say undefined. Okay, there's no value that will work out there. You punch in your calculator says error, domain error. Yeah. No, what we say is that again, imaginary is just it's such a bad word uh, because it leads us to think that it doesn't have any part of this world, and it does. Um, Definitely not imaginary. No, no. Okay. Log base 10 of x is equal to negative 3. That means 10 to the negative third power is equal to x. If you take 10 to the negative third power, you get 1 over 1,000, or yeah, 1 over 1,000. 1,000. Okay, let's look at the last 4 problems. I'm going to digress to quick talk about the graphs. And so you don't have to write this down, but please watch this very quickly. Yesterday we talked about a graph, say y equals 3 to the x. Where did that cross the y-axis? 0, 1. Okay? And it had a horizontal asymptote of y is equal to 0. Everybody agree? And I told you that there is a relationship between y equals 3x and then the other graph, y equals log base 3 of x. What is the relationship between those? They are, starts with an I. Inverses. If remember, inverses switch domain and range values. They switch x and y values. So if I switch the x and y values, what do I come up with? 1, 0. So this is going to cross at 1, 0. Okay? Furthermore, if you switch the x and y values of this, instead of getting y equals 0, you get x equals 0. So it doesn't have a horizontal asymptote. It has a vertical asymptote. Okay? And if you also remember, the graph of inverses get flipped over the line, y is equal to x. And when you flip it over, you get this shape. Right? So that's what the graph of y equals log base 3 of x looks like. So instead of passing through 0, 1, it passes through 1, 0. And what did we just say? Log of 0, we tried that, right? Log base, letter E, it's in log base 2 of 0. If you plug in 0, do you get an answer for logs? Can you plug in 0 and get a result for logarithms? Can you plug in negative numbers? You can for exponentials, but you can't for logarithms. It's not part of the domain. You can only plug in values greater than 0. But look at the range. Can you get out negatives? Can you get out 0? Can you get out positives? Yeah, but the domain is restricted. So we'll do these 4 problems and we'll be done. They say write a function. What do you notice? All these graphs go through what point? 1, 0, just like you thought. So we want to write a function y equals log base a of x. So we need to figure out what a is. Our y value is what in this problem? 2 equals log base a of 25. What does that mean? Interpret it for me. A squared is 25, so therefore a is 5. So we know the equation is y equals log base 5 of x. That's our function. Look at the next one. Our y value is -1 equals log base a of 1/6. A to the -1 is 1/6. A is what? A is 6. $10,004. 4 is equal to log base A 10,000. Whoa. Sorry. Log base 6 of x. Thank you for speaking up. A lot of times I make the same mistake in each class, but you know I didn't make that one before. Okay, a to the 4th power is 10,000. What's a? 10. So y equals log of x. Why don't I have to write 10? It's the assumed base. And finally, this last one, y is 1 is equal to log base a of 7. What number do you take to the 1st power to get 7? 7. So y equals log base 7 of x. What do you think about that? Make sure you kind of focus on, I know some people had some questions about their assignment from yesterday. We got about 10 minutes where we can ask a few. I do need to get some information to Haley, or other people are going to be gone next week. Your assignment is, where'd it go? There it is. One through 29 odd. It looks like a lot of problems, but they go pretty quick. I think we did about 40 problems a day in class or so. So